In the previous videos, we discussed about solving a differential equation, ordinary differential equation, by using separation of variables. That means that if you write the differential equation as dy over dx equals to, if you can write a function of x times the function of y separately in the product form, then you can change. If you can separate that way, then you can write in the variable separated form, meaning that you can isolate y terms and dy in one side and x terms and dx in another side, right? And then we integrate it that way. Now, on the next method is the linear first order differential equation. That means that if the differential equation is in this form, dy over dx plus px times y equals to q, that should be qx, okay, qx, then this type of equation is called linear equation. And how do we solve this is you multiply by the integrating factor on both sides, right? After you find out the integrating factor and multiply both sides by the integrating factor, then the left hand side can be written as d over dx, the whole left hand side, okay, times integrating factor d over dx of integrating factor times the y. You can write that way, equals to, on the right hand side you write integrating factor times qx, right? That's what we did. Now, so if the differential equation is non-separable and non-linear, then how do we handle that type of problem, right? For some example, I mean, not all differential equation can be linear or separable. Some of them may be non-linear, non-separable. For example, look at this example. There is dy over dx equals to negative y squared plus 2xy over x squared plus 2xy. Look at this. So this is not linear definitely because there is y squared, right? And this is not separable because you can take y out, but if you take y out, y plus 2x left, right? So you cannot separate because they are intermixed, they are mixed, okay? So how do I solve these type of equations? That is the thing that we want to talk here, okay? Let us solve like the straightforward way. What I'm trying to do here is, what I'm going to do is I want to write this in the differential form. So I'm multiplying both sides by x squared plus 2xy. You will get like this. So you will get x squared plus 2xy and the times dy over dx equals to, you can write y squared plus 2xy, right? And if you bring negative, right, negative of that, if you bring that to the left side, you can write, or this can be written like this, right? So y squared plus 2xy, right? And then plus, you can add x squared plus 2xy, right? And then dy over dx equals to 0. So can you think of a function whose product rule, when you do when you find the derivative using the product rule, you get that? You can think of like this, right? So you can you write this like d over dx, right? And can you write this as xy squared plus x squared y equals to 0? Can you think of like that? Because see, so do you think that the derivative of this function is that, right? Let us try, okay? So if you try to do that, if you try to calculate that, what do you get? You get basically, look at this. This is the product here, right? This is also product, right? So if you use the product f times g thing, then what you get here is you get y squared plus, because the derivative of x is 1, right? So y squared plus x times 2y dy over dx, right? Plus there will be 2xy for this one, right? F z. So the derivative of f is 2x and then y plus, so f times g prime, right? So x squared dy over dx, right? So what do you get? You get, there are two terms without the derivative, so you will get y squared plus 2xy, right? And then plus you get 2xy plus x squared, that is x squared plus 2xy, right? dy over dx equals to 0. You see that? And then see, so basically this thing can be written the derivative of this form, right? But it was not obvious, okay? It was not obvious. So we will learn how to find out that function that is the derivative, which derivative is the whole left hand side. and the 0 on the right hand side. So in this case, you can integrate, right? Let us integrate on both sides to solve this. Let us integrate that. So if you integrate, you will get xy squared plus x squared y equals to a function c, right? A constant c, or a function c of y. You see that? Because we are finding the derivative with respect to x, okay? So I'm integrating that, okay? I'm integrating that equals to c. So this is the final answer. You see that? This is the final answer. But here the problem is, how do I find out what is this function from here? It is not straightforward. It was a simple function. That's why we were able to estimate, or we were able to guess that. But in general, how do I find out this function? How do I write, or when can I write? What is the condition that I'm able to write the left hand side as a derivative of certain function? Okay, so let us talk about that. So let us suppose that this is like m, okay, m, and this is like n. Okay, so in the differential form, you can write this as like m dx, m times dx plus n times dy, right, equals to 0. So it is like dy over dx, and then I wrote that this as dx with dx, and then this will as dy. Okay, so what is m here? M is y squared plus 2xy, and what is n? N is x squared plus 2xy. Okay, guys. Now, so what is the derivative of m with respect to y? If I find out the derivative of m with respect to y, what do I get? So m sub y, okay, the derivative of m with respect to y will be 2y, okay, and then plus 2x, right? I'm finding the derivative of m with respect to y, meaning, so x will be considered as here. The x is considered as, so m sub y is the partial derivative of m with respect to y will be y, the derivative of y squared is 2y plus this 2x is considered as a constant, okay, and then y, so this will be just 2x. How about n sub x? If you find out the derivative of n with respect to x, you will get 2x plus 2y, right? Because whenever you do that, x is the derivative of x is 1, so what is left is 2y. Okay, look at this. This m sub x and n sub y are equal. So when is, that is the answer for that. So when the whole left hand side can be written as the derivative of some function is if the derivative of the first that comes with the dx, if the derivative of the first with respect to y and the derivative of the second that comes with dy with respect to x are equal, then in that case you are able to write down the whole left hand side as the derivative of some certain function. Okay, so let me first write down the definition of exact equation, okay, exact differential equation. Okay, so let me write down the definition. Definition is exact equation. The first order differential equation, the first order. So when we call exact is if we can write the whole right hand side, whole left hand side as derivative of certain function, then it is called exact equation, right? The first order ODE of the form m plus n dy over dx, or you can write m dx plus n dy equals to 0 is called exact if there exists a function psi such that psi is a function of x and y, okay, such that d psi over dx, okay, d psi over dx equals to m plus n dy over dx. Because what I was saying is this equation, any equation of that form is called exact if there is a function psi such that the whole left hand side can be written as the derivative of that psi. Okay, so if you do that, what do you get there then? So see, this psi is a function of x and y, right? Let me write down here x and y. Okay, x and y. So if you do that, what do you get? Let me write down here. So if you find out the derivative of psi with respect to x, so you will see this kind of like derivative in calculus 3. Okay, so because since there is x and y, what I'm going to do here is I'm going to do, so what is the derivative of psi xy with respect to x? So you need to find out the derivative of psi with respect to x, and then so here y is function of x. Okay, so y is a function of x. So what I'm going to do here is, okay guys, so let me find out the derivative of the left hand side. Okay, so this is a function of x and y. So here also y is a function of x. Okay, so when you find out the derivative of psi with respect to x, you write d psi xy over dx plus, so although this psi is a function of x and y, I'm finding with respect to x plus, and then I'm finding, because it is the partial derivative case, right? So what I'm going to do is I'm going to find out d of psi xy over dy times dy over dx equals to what? You got m plus n dy over dx. You see that? So this is written as psi sub x, partial of psi with respect to x. Okay, and then plus this is psi of y and then dy over dx equals to m plus n dy over dx. Now let us equate that. See, the first term must be equal to first term, psi of x equals to m. Okay, and then the second term must be equal to second term. There is dy over dx equals dy over dx. So you need to have psi y equals to n, right? So this is how you can define now. Okay, this is how you can define the first order ODE of the form m plus n dy over dx equals 0 is called exact if there exists a function psi xy such that psi x equals to m and then psi y equals to n. If this is the case, then we call that this equation is the exact equation. In other words, this equation is called exact if there is a function psi so that the whole left hand side can be written as the derivative of psi with respect to x. Okay, so if you do that, see, the whole left hand side, this thing is equals to d over dx psi xy. Now what I did is I was trying to find out the derivative of this psi xy with respect to x. That means because y is a function of x, you need to write derivative of psi with respect to x plus derivative of psi with respect to y, and where y is also function of x, so we need to use the chain rule there. Okay, so this is the condition for a function to be for a differential equation to be exact. Okay, so now I'm going to write down a formula, actually a theorem. Okay, I'm going to write down a theorem there. Okay, so let us look at this theorem first. Okay, what does the theorem says is, let the function m sub y is the partial derivative of m with respect to y, and n sub x, which is the partial derivative of n with respect to x. Okay, be continuous in an region r, in the region r equals to alpha, x between alpha and beta and y between gamma and delta. Then this equation m plus n dy over dx equals to 0 is exact if and only if m sub y equals to n sub x. So this is a quicker way to check the exactness. Okay, if the derivative of m with respect to y is equals to derivative of n with respect to x, then they are exact, meaning that then we can write the left hand side as a derivative of certain function psi xy, right, with respect to x, and then you write equals to 0, and then to solve it you just integrate on both sides. You will get psi xy equals to c is an answer. Okay, so the easier way to check the exactness of a differential equation is the derivative of m with respect to y, it must be equals to derivative of n with respect to x, partial derivative. Okay, when you find out the derivative of m with respect to y, you consider x as a constant. Similarly, when you find out the derivative of n with respect to x, you need to consider y as a constant. Okay, so this is what the theorem says. Let us apply this theorem right away. Okay, so it says that is the differential equation 2xy minus 9x square plus 2y plus x square plus 1 dy over dx equals 0 exact? We will use this condition to check whether it is exact or not. If it is exact, then what we will do is we will apply that definition to find out the answer psi. Okay, so let us do solution. Here, what is m? M is this thing, right? So because this is dy over dx, the function that comes with dy over dx is n. Okay, m is 2xy minus 9x squared. What is n? N is 2y plus x squared plus 1. Okay, so is it exact or not? Let me check. What is m sub y is 2x. What is n sub x is 2x as well, because see, m sub y will be this term. The derivative of this whole thing with respect to y will be the x will be constant. So 2x, the derivative of y is 1, plus this will be 0 because this is considered as a constant when you find out the derivative with respect to y. Similarly, to find out the derivative of n with respect to x, this will be constant. So 0 derivative plus the derivative of x squared is 2x plus derivative of 1 is 0. So that's 2x. So exact, right? Since it is exact, then you can write the left hand side, the whole left hand side, as the derivative of certain function psi, right? Hence we can write d psi xy over dx equals to 0, because the whole thing, the left hand side can be written as derivative of psi xy with respect to dx equals to 0, right? Now, but what is psi? Where psi satisfy, I gave that equation, the relation of the psi in the definition, right? So where psi satisfy, psi of x equals to m and psi of y equals to n. That's what the psi satisfies. Okay, psi of x equals to m and psi of y equals to n. Now, so we need to find out psi. Okay, that is. So what is psi of x? Psi sub x, right? Psi sub x, not of. Psi sub x is m is 2xy minus 9x squared, right? So let's integrate this. What do you get? Psi is equals to, so the integral of this thing with respect to x, meaning y is taken as a constant in this case. Okay, so what do you get here? So the integral of 2x is x squared and then y, right? Minus, what is the integral of 9x squared? Will be 9, and integral of x squared will be x cubed over 3. That will be 3x cubed. And then plus, there will be constant, but that constant can be a function of y, because we are trying to find out the integral of psi with respect to x. When you do with respect to x, the y will be considered as a constant. So when you integrate any function, you will write a constant at the end. That constant can be a number, or that constant can be a function of y, because y is also considered as a constant, right? Now, what we want to do here is we want to write this, we want to use this psi to find out psi y equals to n. Then what is psi y? Psi y will be x squared plus h prime of y, right? Equals to, what is n? N is 2y plus x squared plus 1. You see that? 2y plus x squared plus 1. All right. So now, so what do you get? Look at this. Now let us compare this with that one. Okay. Instead of x squared, there is x squared. So what do we need there is, we need h prime of y equals to x squared plus 1, right? Sorry, 2y plus 1, right? Because instead of x squared, because these two things are equal, right? So x squared and x squared cancel out. If you subtract, then you will get h prime of y equals 2y plus 1. 2y plus 1. 2y plus 1, right? Now what is hy then? So integrate on both sides. h of y will be y square plus y. You see that? And then plus a constant, maybe some constant, just a constant k, right? Because this is hy is function of y only. So what is the value of psi then? Hence psi xy is equals to, let's plug in there, x square y minus 3x cubed, right? And then plus, so you get y square plus y plus k, right? Y square plus y plus k. All right. So this is basically the value of psi. You see that? This is the value of psi. Now, what you can do there is, so what is the final answer then? So this is this. So this whole left hand side can be written as the derivative of this. Okay, guys? So what you get there is, so the left hand side, hence, the given equation can be written as d over dx, that whole thing, okay? X squared y minus 3x cubed plus y squared plus y plus k equals to 0. Now integrate. Integrate, what do you get? The solution will be in the explicit form, x squared y minus 3x cubed, okay, plus y squared plus y plus k equals to a constant, let's say c1 when you integrate. So now there is a number there, right? And let me move this to the right side, and then let me write down this as a the quadratic function of y. So you will get y squared, right, plus this one has y, this one has y. I'll write x squared plus 1 times y minus 3x to the cubed equals to, subtract k on both sides, k, subtract k. So c1 minus k is another constant. Let's say this is a number c. Okay. Now we want to use the initial condition. What was the initial condition? Using y at 0. This was given, right? -3 we get. So what do you get? If you said y at 0 is -3, then x is 0, right? This will be 0, this will be 0. So you'll get y at 0 square. That is y at 0, because y is a function of x, square, plus this will be 0 plus y at 0 equals to c. That will be -3 square plus 3 equals to c. So c is equals to 6. So what do you get the final answer then? Final answer is you get y square plus x square plus 1 times y minus 3x cube minus 6 equals to 0. That's what I got. Okay, now, so the question is also asking, this is one answer, interval of validity. So how do I find out the interval of validity? You need to solve for y, right? Because if you solve for y, then you can see where the y function is defined, or continuous, not continuous, like that. Okay, so to find an interval of validity, to find the interval of validity, we solve the solution, this solution for y. For y, we need to solve explicitly for y. Okay, solve for y using quadratic formula. Using the quadratic formula. Okay, guys, so let us solve this using the quadratic formula. Then what do we get? What we get there is, so it is like, you see that this is like ax squared, this is like, so it looks like ax squared plus ay squared plus by plus c, right? So how do you write that? Using quadratic formula is, you can write y equals to -x squared plus 1 b plus minus under the root b square is x squared plus 1 square minus 4a, and then c is -3x squared minus 6, right? That will make plus, and then 3x squared plus 6. That's what you can write. You see that? And then divide by, you can write as 2 times a is 1. If you simplify that, you will get -x squared plus 1, okay? and then plus minus. If you simplify this one, you will get x to the 4 plus 2x squared plus 1, because this is x squared plus 1 times x squared plus 1, right? And then plus 4 times 3 is 12x squared plus 24. Okay, divide by 2. And what do you get? Negative x squared plus 1 plus and minus under the root. What do you get? Is the highest degree term is x to the 4. Yeah, this is 3x cubed. Okay, guys, 3x cubed. So 3x cubed will give you 12x. So x to the 4 plus 12x squared plus 12x cubed plus 2x squared plus 25 divided by 2. So what is the interval of validity? So the solution, this y is a function of x, is defined only if this quantity is positive, right? Only if this quantity is positive, right? So, but by the way, if you use the initial condition, which one should we pick? Should we pick plus or minus? So if you pick the initial condition, so what is the initial condition? Y at 0 equals to negative 3, right? So let us set y at 0. What do you get? It will be 0 minus 1, and then plus and minus, it will be 0, 0, 0, and then this will be 25. Root 25 will be 5, right? Should we take plus or minus to get negative 3? I think we need to take negative, because if you take positive sign, you will get positive 1 and positive 5. So negative 1, positive 5. 5 minus 1 be 4 divided by 2 will be 2. But we need negative 3. So we need to take negative sign to satisfy the first condition. So we need to take negative sign. Take negative sign. Meaning, what is the final answer then? Y of x equals to negative x squared plus 1, and then minus under the root x to the 4 plus 12x to the cubed plus 2x squared plus 25, and then divide by 2. Okay, so this is the solution, is the explicit form of the solution, meaning that we are solving explicitly for y, is the required solution. Okay, by using the initial condition. Now, so how do I find out the interval of validity? The solution exists if that thing is positive, right? If x to the 4th plus 12x to the cubed plus 12x squared plus 25 is greater or equals to 0. You see that? So this third must be greater or equals to 0. Now, if you want to find out where it is greater or equals to 0, you can use calculator. Use calculator, graphing calculator. So what you do is you plot this in your graphing calculator. Okay. After you plot this, you will see for what values of x this value will be positive, meaning this will be, the graph will be above x-axis. For what value of x, that will be above x-axis. Okay. So I used this in calculator and I found that if x is greater than negative 1.39, if x is greater than negative 1.39, then this guy will be positive. Okay, this guy will be positive or 0. So hence the interval of validity is negative 1.39 through infinity will be the interval of validity. Okay, guys. So we will do a couple more examples on the exact equation, but this is how actually you solve an exact differential equation. Okay, guys. Thank you.